Alright, in this video I'm going to be discussing the horizontal and vertical asymptotes of a few different functions, and I'm also going to touch on whether or not these functions are going to have any slant or oblique asymptotes or any holes or removable discontinuities. So let's start with this first function, f of x equals 10x squared plus 1 divided by x to the third power. Let's talk about vertical asymptotes. Now remember, for vertical asymptotes, it's going to have asymptotes at any x values that would make our denominator equal to 0. And if I have x cubed on the bottom, the x value that would make that happen is 0 itself. So I'm going to have a vertical asymptote at x equals 0. For horizontal asymptotes, let's see, horizontal asymptote. Oops. For horizontal asymptotes, we need to think about the exponents of the degree of the top and the bottom polynomial of our rational function. So we're thinking, is it bigger on the bottom, bigger on the top, or are the exponents the same? In this case, our exponent or degree is bigger on the bottom. Anytime it's bigger on the bottom, my memory trick is Bobo, bigger on bottom means y equals 0 is going to be our only horizontal asymptote. So far we have x equals 0, vertical asymptote, y equals 0 is our horizontal asymptote. Alright, let's talk about whether there's going to be any slant asymptotes or holes just by thinking about it. So our rule for slant asymptotes is that we can have a slant or oblique asymptote anytime the degree of the top is 1 more than the bottom. But we already said that the bottom is bigger, so the top is definitely not bigger by 1, so there's going to be none for slant asymptotes. And for holes, or what we call removable discontinuities, we're looking to see if we were to factor the top or the bottom, if there would be any common factors that we could cancel out. But looking at this, I've got x cubed on the bottom, and there's no way I can factor out an x on the top and cancel a factor of x, so there's also going to be no holes for that one. Alright, let's take a look at the second function. My second function, I've got f of x equals 3x squared plus 2 over x minus 2. Let's start again with vertical asymptotes. Again, I'm looking for any values of x that would make this denominator equal to 0, and the value of x that would make that happen is positive 2, because positive 2 minus 2 is 0. So I'm going to have a vertical asymptote at x equals 2. For horizontal asymptotes, again, I'm comparing the degree of the top and the bottom and seeing which one's bigger or if they're the same. And if I look here, this has an exponent of 2, it's squared, and on the bottom it has a first power since there's not an exponent there. So this one is bigger on top. So I remember BOTN as my memory trick means bigger on top. There's going to be no horizontal asymptotes for this rational function. Next, if I think about my slant asymptotes, remember that happens anytime the top is bigger by 1, and in this case that is happening. So we know there will be a slant asymptote, and the way we can find the equation of that slant asymptote is by doing division, dividing this top polynomial by our bottom polynomial, and our quotient polynomial will be the equation of our slant asymptote. So I'm going to divide the top by the bottom, so I'm going to do synthetic division, and I'll have a 2 in my box, 3, a 0 because there's no x term, and a 2. Bring down my 3. 3 times 2 is 6. 0 plus 6 is 6. 6 times 2 is 12. 12 plus 2 is 14. So 14 is my remainder, and 3 and 6 are the coefficients of my quotient polynomial. Since it was squared, now it's to the first power 3x plus 6. So the equation of my slant asymptote will be y equals 3x plus 6. Remember, it's just the quotient polynomial, not the remainder. Okay, and last, let's check for holes. again, if I think about the top and the bottom and if they will have any common factors, I've got an x minus 2 on the bottom. Is there going to be a way that I can get x minus 2 on the top by factoring this or something of that sort? And I'm not going to be able to do that, so there would be none if you cannot factor and cancel a common factor. All right, last example. F of x equals x divided by 2x minus 1 for vertical asymptotes. I'm thinking what x value will make my denominator equal to 0. If you need to actually set it equal to 0 to solve, you can, and we'll end up with x equals 1/2. So I'll have an asymptote at x equals 1/2. For horizontal asymptotes, we're looking at the degree of the top and the bottom, and when I take a look, both of them are to a power of 1. So any time that I have exponents are the same, we have EDC as my memory trick, we're going to divide the coefficients. So on the top we have a 1, since there's no coefficient there, and on the bottom we have a 2. So dividing those, we will have y equals 1/2. So x equals 1/2 is our vertical, y equals 1/2 is our horizontal. For slant asymptote and holes, there's not going to be any slant asymptotes, because remember that happens when the numerator is bigger by a degree of 1 and they are the same degree. And for holes, we want to see if we can cancel a common factor on the top and bottom, and we're not going to be able to do that either, so there's going to be none. But we just always want to check for all of those things whenever we're talking about horizontal and vertical asymptotes and other discontinuities.